Okay, let's get started. This is the Bridge Resiliency through Scour Countermeasures session. My name's Laura Gerard. I'm with FHWA's Resource Center. I'm new to the position, formerly of Fed Lands, and I've been involved in countermeasures now since my grad school research, which led to the development of HEC 23. So our first presentation is, we've got three presenters. And the first is, excuse me just a moment while I get there. The first is Joe Scannell. Joe is the president, CEO, and co-founder of USES Corp. He's a former engineer with the Connecticut Department of Transportation and the primary author of a United States patent for monitoring structural instabilities due to environmental processes. Dave Claman is the transportation manager for the preliminary bridge section at the Iowa Department of Transportation and has 34 years of experience in the hydrology and hydraulics engineering field. He is also the DOT's expert regarding drainage disputes, bridge scours, stream geomorphology, 2D hydraulic analysis, FEMA floodplain management issues. Mike Hogan is a supervising engineer at Connecticut's DOT hydraulics and drainage section. He has more than 30 years of experience in hydrology and hydraulic analysis and modeling. He is a member of AASHTO's Committee on Design and TCHH. Wesley Peck has 22 years of experience with the Tennessee DOT and currently manages the hydraulic design section of the Structures Division. Joe?
Good afternoon. So we'll be as quick as we can. Well, I'll be as quick as I can to make sure that there's time for the other speakers. So what I'll do today is just going to talk a little bit about our BridgeWatch system, formerly ScourWatch way back in the day. We started in 2001. That's when I left my DOT job to pursue this product, which obviously I was passionate about. So that product, at that time, we monitored only just the radar stations, which was a level 3 single pole product. But we thought it was great then until you see what we have today, which is the digital precip products that we see with the dual polarization. So that was one of the primary sources of data we used. What I'm going to do is bring up the architecture. This is a simple schematic of what BridgeWatch does. It pulls in data sources, web-based data sources like precip, hydrology, USGS, real-time gauging, seismic information from ShakeCast. Today's product, which is our 7th generation at this point, brings in a multitude of sources. Obviously, we've got snow melt for the snow mountainous regions like Idaho, a client of ours. We're dealing with earthquakes. We're dealing with Hawaii. We had to deal with earthquakes recently and now flooding from the hurricane. That's a client of ours as well. We monitor nationally over 13,000 bridges. We just picked up Puerto Rico, so that's the newest contract. So there's quite a bit of use case here. So today the purpose was to have you, since we've been around for 18 years and the technology's been in practice, to hear stories of some of the things that have happened having had the system in place. So with that, I'm going to bring up Dave Claman. He's going to talk about the deployment in Iowa, the things that they've done there. Dave?
All right. Thanks, Joe. I think next time I'm going to revise my bio. I don't know that I want anybody to know I've been around for 34 years in the hydrology and hydraulic field. That sounds like a long time. Anyway, some history on Iowa's Scour program. We brought in BridgeWatch around 2006 to monitor our Scour critical bridges. And, you know, we used it as a monitoring program to basically notify our maintenance people when the potential for flooding was to occur, right? Because when Federal Highway mandated that we put in these POAs, one of the things you have to put in writing is the fact that when the flood hits a certain level, you have to, as an agency, go out there and either close the road or monitor it in some way to provide safety to the traveling public. So I didn't feel comfortable as the hydraulic engineer to do all these scour analysis and say, okay, you know, district, you got these many scour critical bridges, and when it floods, you got to make sure you close the road or go out there and monitor it and see you later, you know. that puts a kind of an extra burden on the maintenance folks to have to get up in the middle of the night and try to figure out, well, did it rain enough to flood enough for me to go out there and look at these bridges? So what BridgeWatch does is kind of takes that human element out of that. It allows, obviously, the program to monitor the rainfall in the USGS gauges. And then when it hits the threshold that you've given it for that bridge site, it will send a text message to the maintenance people, and then they only have to get up in the middle of the night on a weekend when they have to, right? Instead of every time it rains. So I'm not going to talk about the Scour Critical Bridge stuff. I'm going to talk a little bit more about how we've taken the BridgeWatch program and now expanded it into roadway overtopping. We surveyed our districts, asked them, okay, what are the most frequent roadway overtopping locations? So we have 6 districts in Iowa, and we got a 50% response rate. 3 of the districts responded, okay? So since they responded, guess what? We're going to hook you guys up with the BridgeWatch program, so we're going to help you when your roadway is overtopping. We're going to give you an alert so you can be proactive and close it instead of getting the notification from the state patrol or from the local county sheriff's office that your highway's overtopped and you need to close it. So what we ended up with was 26 highway locations that in 17 counties. District 1, 6, and 2 were the lucky districts. And we've got bridge sites ranging from 4 to 330 square miles in drainage areas. So, or not bridge sites, the basins. So these are roadway overtopping sites that they told us had frequent overtopping. So 26 locations. One of the benefits that Iowa has is we actually, at the University of Iowa, as a result of the 2008 flood, the University of Iowa was directed by legislative action to they created the Flood Center. And what that is their main mission, of course, is to try to reduce flood damages in the state of Iowa due to floods. And one of the things they came up with was this flood forecasting model, where they can actually take rainfall, and as it's falling out of the sky, they capture the Doppler radar, and they actually then model or forecast the flow that would occur along any stream in Iowa. So with this modeling then, this hydrologic model that's statewide, BridgeWatch is tapping into that data so that we can know, based on this modeling, where a site has the potential for roadway overtopping. The other thing that the University of Iowa has is these sonic stage sensors, okay? So they've built these at the university. They're very compact. They attach into the bridge, and what it does, it sends a signal down, and it actually measures the water level real time like a USGS gauge. But it's a little simpler, it's a little obviously less costly, and it can then monitor those sites where the drainage area is not where we don't have large drainage area for these roadway sites. The smaller drainage areas, we actually put up these sensors because the reaction time would be a little longer with the flood forecasting model that they have as opposed to the real sensor gauges. So again, pick a threshold by which the roadway is going to overtop, usually 1 to 2 feet below the roadway. That would be a point at which the sensor would trigger an alert from BridgeWatch, and BridgeWatch then would send that alert out to the maintenance people on their cell phones. One of the things too that obviously was part of this project was we had the University of Iowa, you need to do a hydraulic analysis at these locations to actually know what flow rate would cause the roadway to overtop. So they developed the rating curves, and the sensors provide then the projected, the hydrologic model shows the projected flood forecast flows, and also the gauge obviously shows you the exact stage. So the gauges are a lot more straightforward. It's related exactly to the low road grade elevation, but the forecasting model, we had to use rating curves and flow rates to correlate that. So we had our first year of implementation for this roadway overtopping in BridgeWatch. And what we want to do is capture the accuracy, obviously, and then if the garage supervisors realize a benefit from it by not having to go out in the middle of the night when they don't have to, and only do it when obviously the gauge or the hydrologic model tells them that we're going to potentially exceed the threshold. So we think this is a good way to use BridgeWatch for a proactive approach, not reactive. And we think it'll provide value to our maintenance folks and, in the end, public safety. And with that, I'll turn it over to Wesley.
All right, when Joe asked me to come and say a few words about BridgeWatch, I said, just don't make me go after Iowa. And I don't know, I guess were we late on a check, on an invoice, Joe? Because Iowa's doing more interesting things than we are. We were one of the earlier adopters for BridgeWatch. We've been using it since about 2004, and that was based on some interest from our our Federal Highways Division Office, the bridge engineer over there, who's actually it's Paul Sharp, the Scour Program Administrator now for Federal Highway. Let's see. We have about 19,000 state or local bridges in our inventory system in Tennessee, and about 85% of them are over water, so that's around 16,000 bridges altogether. So, when we have a really big storm, it's kind of hard to figure out where to go first. And we brought in BridgeWatch to monitor all of our scour critical and unknown foundation bridges to meet Federal Highway Administration requirements, similar to what Dave was talking about earlier. So at this point, we have 951 structures with unknown foundations and 718 scour critical structures that we're still monitoring. Our numbers have been going down slowly over all that time. And what you see here is, let's see, I believe that's all of our, I'm not entirely sure what that is. Are those the gauges? Okay. I can't see it. I can't see it in really small here. Yeah. All right. And now what you see here, those are all the monitored bridges that we have in Tennessee. Those are our unknown and scour critical bridges. So I just put that up there so you can see that's, we're going from 17,000 bridges overall to these, 11 or 1,200. So it helps us keep track of that. Now, in 2010, we had a very significant flood over a good portion of the state, and these were all of our call-outs at one time on that. And that looks like a lot, but it's still much better than having to try and go to each one, or having the inspectors trying to use their judgment to figure out which ones they think they need to go through first. And that's just an example of an alert event that just happened to be on my screen at the time when I was doing these slides a couple of weeks ago. But you can kind of see it's overlaying the NexRad product for a certain period, a certain storm, onto the geography of the state, and you can see the bridges that it's calling out there. And I use this one as an example because this was a smaller storm, and we only got the 3 alerts. And now I can't tell. I can't tell on this small screen, but that's an area on the extreme western end of the state, and our bridge inspectors for that area are mostly in Jackson, which is over in that green part you see in the center of the screen where they didn't get that much rain. So the idea here being, like Dave was saying, they know where the storms happen, so they know when they need to go out there. So, the bridge inspectors would, without this system, they may have been, it didn't rain all that much, we don't need to go over there. So it catches a lot of our smaller scale storms that are high intensity in a smaller drainage area, or smaller area. And just one example of one of our success stories with it, we had a bridge on State Route 203 over Turkey Creek in our western Tennessee area. They had a major flood event in 2009. The bridge inspectors got the alert, they got out there, and they determined that they had gone from 8.4 feet to 17 feet of exposed pile since the last time they had been out there. So that meant they had maybe 3 feet of embedment left. And I'm not a geotech engineer, but 3 feet's not all that much for a load that high. So they shut it down until they could get in there to reinforce it and repair that foundation. So we consider that a major victory because we may not have known about that one for a while longer if we hadn't had our alert to go out there and take a look at it. And, well, I already said all this stuff, but now it has pictures. But you can see the amount of riprap that ended up in there after that. And it potentially saved us a bridge replacement, if we hadn't got to it in time and there'd been a failure on it, it saved us, $450,000 roughly bridge replacement, and also, potential loss of life if somebody was, trying to cross it when it failed. And now I'm going to turn it over to Mike Hogan from Connecticut.
Thanks, Wes. So first I'm going to speak a little bit about how we're using the system, and then share another flood event story. So Connecticut has this system since 2004. BridgeWatch is a part of our monitoring plan. It's included in our plan of action for scour critical bridges. We currently monitor approximately 500 structures within the system. These include the scour critical bridges, bridges with design countermeasures, some of our metal culverts that we're keeping an eye on because they're deteriorating and we're more frequent inspection. And then we also use the system to manage some scour monitoring devices that are on the historic bridge in Mystic, Connecticut. Our scour critical bridges include both state road and town roads, as we inspect the town roads as part of the NBI. However, the towns are required to develop their own POAs, implement them, and maintain them. We're about to install monitors on a second bridge, and we'll also manage those monitors through BridgeWatch. So in March 2010, there was a series of rain events that caused record river stages throughout southeastern Connecticut, and this rain resulted in flooding in the eastern part of Connecticut. We received hundreds of bridge alerts through BridgeWatch during that event for 182 scour critical bridges. The alerts included this bridge, which carried Route 184 in Whitford Brook in Stonington, Connecticut. It was rated scour critical based on a scour evaluation. On March 29th, the bridge had received an increasing level of alerts over a 12-hour period beginning around 11 p.m. The alerts had been generated by a stream gauge that was associated with the bridge in BridgeWatch. Whitford Brook does not have a active stream gauge on it, so how we have the system set up is that BridgeWatch is looking at nearby stream gauges as well as the NEXRAD rainfall. So what I mean by the increasing level of alerts is that we have the certain flow thresholds set based on the gauge discharges for the different frequency events. And as you can see in this timeline here, those when those discharges at the gauge were exceeded. So when one of the bridge safety engineers arrived at the site, who was checking out all the alerts, he immediately saw the bridge was flowing pressure flow, and he took his vehicle and just blocked the roadway and notified the district office that we needed a detour immediately. So unfortunately, we lost the bridge instead. Tennessee was able to, or did not lose theirs, but But due to the early alerts and the response by the engineer, the bridge was closed 3 hours before there was any injury or loss of life. And that's just a picture of the new bridge, which is now on integral abutments that are on piles. They're set back from the main channel.
We can answer questions for you guys. Any
How,
questions?
who receives the alerts? How do you organize within the DOT? I think that's always a question I've had, is like, who's going to be the focus for the software? Is it the bridge group? Is it an operational group?
It can depend
Yeah.
on your organization, really. I'm kind of the centurion for it, but I don't act on it. I'm just kind of receiving the information so I know what's going on. But the districts are really the responsible. We got a district maintenance manager and what we call a district operation manager. They're the ones that actually get the alerts and have to take action with it. We also have a 24/7 operations center, so they also get a copy of it. So you can decide for yourself how that information, how you want to disseminate it amongst your, whether it's centralized or into your maintenance folks or however you want to do it.
Yeah, the system was set up with a permissions infrastructure, so you can set up profiles of varying types of users, and then that includes the content that they'd receive as well. So the policy, we want to make it as flexible as possible, so whatever policy you want to effectuate can be successful through that system.
Our system actually sends out alerts to the local government owners. It's like half of them are local bridges, so it goes out to the county highway department or the city or whoever, and it also goes out to our inspectors as well.
Ours similar goes to the bridge inspectors, the hydraulics and drainage section, the operations center, and we don't send the alerts to the locals. As I said, they're required to do their own monitoring, but we do notify them that we did see the alert.
Any question in the back?
Yeah, I'm curious if you've done any projects where your systems have done any active road closures or activated road closures. So you gave the example of the gentleman that parked his truck in front of the bridge. But have you worked on anything where when a trigger was triggered, I guess, you have some gates that came down or a sign that has to flash a sign that says, hey, on the bridge?
Yeah, we've had a bunch of cities talk about having these closure systems, but we don't have any clients currently that use the gate systems because you'd have to have them at the sites that are scour critical and being monitored for that effectuation. But yeah, you guys, I don't know of any closing gates at any of these structures you guys have. Georgia DOT and others we work with, they close roads all the time during floods, and they do it successfully, having the system in their play. But we have yet to come across a client that's invested in having a closure system.
We did have to, go ahead, Dave.
Well, I saw a few early on. Sometimes it had to do with some atmospheric conditions where the Doppler would pick it up, or hail even. Sometimes if you had hail, that would cause a false positive. I think with the next generation, maybe Joe could speak better to this. I think they refined the Doppler radar systems to be
Yeah.
even more accurate than what we used in the past. So.
Yeah, it has been a significant improvement only as recent as last year, where they released the high definition radar. So we're getting extremely accurate. We're talking about fractional data we had before that's been divided by a multiplier of a division of 16 to 256 in some of the levels. So this the image you showed, Wesley, was actually of the newer precip, and you could see the resolution right away is already higher resolution. We saw a huge drop in notifications coming out of our dam watch system for the NRCS. So that system does 12,000 dams in 47 states. And I've had people call from Oklahoma that had the older version of the software and said, hey, I haven't gotten getting alerts in a while. And we look at the data and they're right at the edge. They almost got an alert, but no, it's just better data, right?
And I will mention too that just because your threshold's a 25-year storm event over 50% of the basin, and you get 51% of your basin with that 25-year event, that doesn't necessarily mean you're going to get your 25-year flood at your bridge site. So that's not necessarily a false positive. That's just being conservative in your alerts to make sure that you got somebody on site when the flooding does occur.
We found a big reduction in alerts also when the original way it was implemented, it uses a drainage, or it uses like, it was a circle, a radius around the structure, and if the rainfall was within that threshold in that radius, then it would trigger an alert. But I think it was Iowa's idea to use like a geo-reference drainage basin. You know, you put the actual basin in the system, and so that way you're making sure you're actually getting that rain in your, you know, system that flows to that bridge, and that helps quite a bit as well.
Thank you, Wesley, Dave, Mike, and Joe.